Under the cold light of distant stars, a new uncertainty moves silently and swiftly through the solar system, drawing attention not because it glows with predictable light, but because it behaves in specific ways that seem to defy every established physical law known about comets. Catalogued formally as 3I Atlas, this ancient, uninvited visitor carries a mathematically precise hyperbolic orbit, a trajectory guaranteeing its swift, inevitable departure from our neighborhood, entirely unbound by the sun's gravitational reach and confirming its origins are elsewhere. It travels at nearly 58 kilometers each second, a vast and quiet witness carrying the immense weight of billions of years, with its estimated age placing it between 3 and 11 billion years old, predating most of the stars still shining in the sky and setting it apart from any object born in this system. This immense velocity, ensuring its escape and preventing its capture into a permanent orbit, immediately established a baseline of predictable mechanics. Yet the object's subsequent motions and emissions seem to immediately rewrite the simple rules that define celestial order, disturbing previous precision and suspending meaning between verifiable natural law and something that quietly resists easy naming. The immediate realization that something so ancient is passing briefly through the human window of time, moving from one unknown destination to the next, instills both deep wonder and a quiet, necessary curiosity about the true scope of the cosmic journey. The core definition of a hyperbolic orbit is crucial here, as it signifies a fundamental difference from every object native to our system, which remain gravitationally tethered either to the sun or to the gas giants, existing only in closed elliptical paths. A hyperbolic trajectory means the object's velocity exceeds the escape velocity of the sun at its current distance, confirming that this traveler is alien not in metaphor but in its physics, having originated outside the gravitational control of the solar system's formative processes. To grasp the implications is to understand that what we are tracking is not debris, but a coherent sample of the galaxy's enormous dark volume, a solitary vessel that has crossed unimaginable distances in profound silence. This distinction between being merely a comet and being an interstellar interloper turns standard astronomical tracking into a genuine search for cosmic precedent, elevating the conversation from orbit mechanics to the fundamental composition of matter elsewhere, demanding a level of intellectual honesty and attention that overcomes past institutional dismissals of the unfamiliar. The initial factual signal arrived through the established discovery mechanisms. Telescopes first recorded its anti-solar tail, a plasma direction pointing decisively toward the sun rather than streaming away from it, a single, visible reversal that immediately challenged physics built on centuries of accumulated observation regarding the effects of solar radiation.
Before we get to that, I need your help. I'm trying to hit 50,000 subscribers by the end of the year, and I need your help. So I would really appreciate it if you could subscribe and help me out.
This phenomenon was not subtle. It was a contradiction recorded in precise time-sequenced frames, forcing analysts to recalculate the cumulative effects of sunlight pressure, solar wind influence, and particle drag as they attempted to reconcile the observation with known physics. None of the standard forces or outgassing models explained why the expected physics of a simple coma had been openly ignored by the object itself, an event that became both a small revelation of what is possible and a quiet warning to astronomers that the rulebook was incomplete. The sky, though ultimately obedient to universal laws, seemed to temporarily refuse to align with the theoretical expectations written into human models, leaving every previous certainty broken in silent, measurable defiance. While the tail later turned again, aligning properly after some days, the momentary reversal suggested a far more complex process than the passive sublimation of dust and gas driven solely by solar heat, powerfully validating the long-held vigilance of observers who instinctively knew that truth sometimes appears as a momentary defiance of simple expectation. Spectroscopic measurements added a new, profound layer to the observational disturbance, revealing an extraordinary chemical composition that defied purely natural explanations for cometary formation within any known star system. Within the faint light scattered by the object's coma, spectrographs detected the signature of atomic nickel vapor, which was surprising enough in quantity, but further scrutiny exposed the undeniable presence of nickel tetracarbonyl, a compound entirely unknown in any natural cometary environment and fragile in the extreme. The readings were rigorously cross-checked across independent observatories and verified under separate calibrations. Yet the same precise, unexpected spectral lines persisted across multiple domains, challenging fundamental assumptions about astrochemistry as much as celestial dynamics. Scientists accustomed to predictable displays of water ice, silicates, and common metals now faced materials familiar only in industrial chemistry: volatile, synthetically relevant, and thermodynamically fragile compounds that should not survive solar proximity without immediate, rapid disintegration, and which match nothing in astronomical databases of naturally occurring cosmic ice. This chemical improbability, meticulously verified yet impossible to replicate naturally, forced researchers to admit that the inability to explain its formation left them with descriptions of an object that resists all established categories, demonstrating that nature still exceeds human comprehension and that genuine wonder remains intact. The analysis of the orbital data immediately deepened the mystery, revealing subtle, persistent deviations and patterns of motion inconsistent with the sole influence of gravity, forcing the term non-gravitational acceleration into the official, cautious reports as a necessary, if unsatisfactory, designation. The object accelerates minutely where physics predicts stability, a deviation that is small enough to be missed by casual observation, yet definite enough to be statistically measurable, creating a quiet tension between verifiable evidence and long-standing assumption that the object is a passive passenger. Calculations meticulously accounted for every known planetary influence, the solar wind, and the known effects of outgassing from a traditional comet, but measurable residuals in the trajectory consistently remained, indicating that a measurable acceleration occurred where no verifiable external force could be identified. Furthermore, the path of 3I Atlas near the gravitational fields of Jupiter, Venus, and Mars registered not as simple passive drift, but as subtle, purposeful shifts that bore a striking, unsettling resemblance to controlled path corrections, however minute they were.
Before we get to that, I need your help. I'm trying to hit 50,000 subscribers by the end of the year, and I need your help. So I would really appreciate it if you could subscribe and help me out.
The profound contrast between a mathematically traceable, predictable orbit and an unpredictable, seemingly self-driven behavior within that path became the silent, unsettling core of the intrigue, turning scientific observation into a sustained philosophical confrontation, moving from doubt toward the unsettling potential of revelation. Facing this persistent, measurable anomaly demands a level of intellectual courage to overcome established bias, transforming the issue from a mere claim into an undisputed record, confirming to observers that the cosmos operates within a continuity of order, even if that order is vastly more complex and unknown than previously codified. The failure of established models to account for the object's full behavior suggests that the forces governing objects from beyond the solar frontier are either completely new to science, or they indicate a mechanism of self-propulsion that must be openly considered as a possibility, since the data explicitly rules out all standard cometary processes. It is not an act of radicalism to consider the unconventional. It is an act of responsible science when the conventional models are repeatedly shown to be incomplete, restoring dignity to the discipline that endures uncertainty by always following the data, no matter where it leads the mind. The measured acceleration is not a belief. It is a fact recorded in telemetry, which demands a reasoned and skeptical response that avoids premature certainty. Amid this growing debate, a familiar voice entered the discussion, proposing an explanation that most in the official cautious field sought reflexively to avoid. Harvard astrophysicist Avi Loeb analyzed the compounding records and suggested that 3I Atlas might not be a natural body at all, elevating the discourse beyond simple chemistry. His analysis grounded the idea in measurement and observation, not fantasy, pointing to the combined converging signs of non-gravitational acceleration, unusual chemistry, and anomalous tail orientation as indications of potential engineered design, or perhaps a complex technological artifact. He specifically quantified the risk, giving the object up to a 40% probability of being a technological construct, perhaps a probe or a vessel releasing smaller, as yet undetected instruments, a calculation based on weighing the failure of natural explanations against the coherence of the anomalies. This was not a claim of certainty, but an honest, quantified demand for comprehensive, unbiased investigation, reminding the scientific community that when standard physics fails repeatedly to account for measurable effects, the duty of the discipline is to question core assumptions, not preserve institutional pride or established categories. Though the claim immediately divided public audiences and established institutions, it commanded attention because it asks only that observers accept what objective data already show, even if those facts disturb the expectation of simple comfort, allowing for a healthy intellectual recalibration of what constitutes the known universe. The institutional responses following Loeb's measured discussion became notably more guarded and procedural. While NASA and the European Space Agency maintained their stance of calm and procedure, reiterating that the comet posed no immediate threat, the measured silence between official updates grew perceptibly longer. Public briefings emphasized safety above all else, repeating the undeniable fact that the closest approach, approximately 1.8 astronomical units, or 167 million miles, was safe by interplanetary standards, but beneath this necessary reassurance ran a palpable current of quiet, organizational tension that spoke louder than the words. Observation schedules were visibly increased, tracking systems refined and doubled, and the sudden large allocation of resources suggested an urgency that the calm tone of announcements tried hard to mask, signaling the subject had matured from mere rumor to an undeniable, high-priority agenda item. Agencies once accused of habitual opacity and secrecy now faced a silent authority, the night sky itself, which offers no privacy to the object of scrutiny, forcing them to observe openly because every major telescope sees the same space, and every data set is subject to comparison by the global community. For those long skeptical of official restraint, the very event brought a profound sense of vindication, restoring confidence that observation is an open, disciplined path to truth that operates beyond bureaucratic interpretation and control. This growing realization fosters an essential identity binding the careful observers. They belong to the few who see clearly that the fragile arrogance of systems built on closed certainty is being quietly exposed and corrected by the unbending authority of reality itself, initiating a gradual move toward serenity. The collective focus and preparation intensified on the coming perihelion, the object's moment of closest solar approach, which was officially scheduled for October 29, 2025, and anticipated as the single most critical opportunity for unambiguous data collection. As the object closes its distance to the Sun, the intensification of radiation and solar heat may strip new, deeper materials from its surface, potentially revealing structures, chemical signatures, or hidden gases unseen before, creating a perfect example of an intermittent reward loop. Instruments across Earth and in orbit, including optical, infrared, radio, and ultraviolet sensors, were prepared and aligned for this unique, fleeting encounter, each beam of analysis seeking the coherence that would finally separate mere speculation from certain truth. The anticipation built without noise, becoming a disciplined, sustained focus rather than a chaotic fear, confirming the audience's deep need for cosmic clarity. For independent observers, this was the point where trust had to meet evidence without institutional filters, the critical hours that promised either definitive reassurance that the object is exotic but natural, or a deeper, more unsettling confusion. Scientists hoped either to prove conclusively that 3I Atlas is merely exotic matter reacting naturally to extreme conditions, or they waited for any small, undeniable sign that the object operates with intention, knowing that either result represents a crucial form of progress. The unified campaign to record the event unites institutions that rarely cooperate, as the desperate need for clarity overrules internal rivalry, confirming that what skepticism truly demands is verifiable, transparent evidence unshaped by the hand of selective authority, deepening the sense of perspective. Yet even as the global instruments aligned for the solar climax, the process was already subtly incomplete, shadowed by a quiet, bureaucratic manipulation of transparency that raised new concerns about the flow of information. The crucial readings exist, specifically the unique, deep infrared data gathered by the James Webb Space Telescope, JWST, but they were immediately sealed behind administrative walls and layers of official time. This information, capturing spectra that reveal how molecules vibrate in the deep cold and offering the precise chemical identity of the traveler, is locked away from public scrutiny. The stated justification for this scarcity is based on standard procedure, an embargo meant to protect scientific teams from distraction and prevent the public from experiencing premature confusion over raw data, yet the duration, stretching up to 74 years for some datasets, unsettles even those who trust the scientific process, turning standard caution into a profound, time-locked mystery. This overload of data that is immediately locked away functions as a partial blindness imposed by institutional design, a deliberate filtering of public perception that holds discovery in suspension like light behind frosted glass. Observers outside official circles sense a genuine dissonance in the contrast between earlier openness and the present prolonged restraint, noting that while raw data can indeed mislead the untrained eye, secrecy also inevitably nourishes the very imagination it is designed to contain, filling the void where clear facts should speak for themselves. The question arises not of intentional deceit, but of proportion. Why must essential data about a non-threatening, receding interstellar body require protection measured in human generations, allowing a quiet anticipation to replace immediate certainty? The scientific community's initial reflexive attempts to explain away the object's anomalous acceleration using conventional models, primarily outgassing, failed to satisfy the demands of precision, which offered a critical intellectual satisfaction to the skeptical observers. The outgassing model suggests that as the sun warms a comet's icy surface, jets of evaporated material act like small, natural thrusters, subtly pushing the object off its predicted gravitational path. While this explains the non-gravitational effects on standard comets, rigorous analysis demonstrated that the observed acceleration of 3I Atlas did not correlate with the angle or timing of its detected outgassing activity, and its motion pattern was too smooth and consistent to be explained by chaotic jets. This methodical disproof of the standard explanation was a victory for intellectual integrity. The scientific method, operating correctly, demonstrated that an explanation must fit the phenomenon, and when it does not, the explanation itself must be discarded, not the data. The subsequent need for an entirely new, non-cometary model for the acceleration served as a profound vindication for those who insisted that the first, easiest answer is often the least accurate, reaffirming that intuition, when grounded in observation, is frequently rewarded. The history of interstellar object detection, specifically the previous passage of Oumuamua, provided a crucial precedent for understanding 3I Atlas, transforming the current event from a unique anomaly into the beginning of a new, repeatable cosmic rituality. While Oumuamua was defined by its geometric shape and lack of an observable coma, it too exhibited inexplicable non-gravitational acceleration, leading to similar debates about natural versus artificial origins, an open cycle of mystery. The arrival of 3I Atlas proves that these are not isolated events, but recurring phenomena, establishing that the solar system is routinely crossed by such visitors, though the specifics of each object are wildly different. This realization, that we are not observing a fluke, but the steady flow of galactic traffic, recalibrates the human position in the cosmos, creating an intellectual satisfaction in recognizing a pattern where previously only randomness was assumed. The comparison between the two objects, one a geometrically strange, tumbling cigar or pancake, the other an apparently icy body with impossible chemistry, suggests that the population of interstellar wanderers is far more diverse and strange than the most imaginative theoreticians have previously proposed, expanding the known universe not by distance, but by complexity. Philosophically, the passage of 3I Atlas has become a crucial test of how truth survives concentrated, relentless attention and how arrogance falls before the unyielding authority of fact. The deeper meaning of the contradictory data reached far beyond simple physics, reminding observers that certainty is a temporary privilege granted only by incomplete knowledge, and that every orbit plotted with confidence must eventually face what lies outside its precision. To witness a celestial body reverse its plasma tail, display forbidden chemistry, and accelerate beyond physical expectation is to remember that the universe still guards its fundamental autonomy and resists simple categorization. When institutions, through their actions or their omissions, are forced to admit what they cannot fully explain, a profound humility quietly replaces the human urge for control, revealing that the unknown does not threaten civilization, but actively refines it toward a reasoned skepticism. The cosmos, through this one transient object, demonstrates that explanation is not ownership, and that disciplined wonder is the highest meaning one can find, allowing initial anxiety to soften into genuine understanding. This exposure of how much of our established understanding depends on untested assumptions is not hysteria, but respect, a recognition that discovery is not conquest, but a gentle, necessary consent granted by reality itself. The persistent failure to definitively classify 3I Atlas under any existing category serves as a powerful moral dynamic, highlighting the humility required in the face of nature's ingenuity and validating the intuition of those who have long sensed the limits of current knowledge. The choice remains stark. Either the object is the result of extremely rare yet natural synthesis processes that we have yet to discover and model, a triumph of exotic astrochemistry, or it is a technological product whose engineering is subtle enough to mimic natural forces yet robust enough to survive deep space travel. The fact that established science must seriously entertain both possibilities without bias represents a profound, redemptive relief loop, transforming initial tension, the unexplained anomalies, into clarity, the recognition of a fundamental scientific boundary, and then into renewed wonder, the scope of possibilities now accepted. This situation confirms the poetic justice of the cosmic order. Arrogance, fueled by overconfidence in existing models, is corrected by simple observation, and the truth, emerging from the facts, restores balance by demanding intellectual honesty. The object, by simply existing, teaches that the universe will always exceed the boundaries of the textbooks. As the comet closes on its dramatic encounter with the sun, the immediate tension finds resolution not in comfort or certainty, but in absolute clarity about the limits of current understanding, which is a deeper form of security. The very light and heat that may expose an engineered design will also inevitably reveal the elegant simplicity of natural law operating under conditions we cannot yet predict, ensuring that in either case the outcome restores a profound, if newly defined, cosmic order. The process of facing this anomaly has already expanded the vocabulary of inquiry, transforming the public's foundational doubt from a weakness into a methodological strength, proving that scrutiny, when applied carefully, is productive. Whatever the object's ultimate final nature, whether the most exotic natural matter imaginable or an extraordinary technological vessel, the dedicated process of tracking its relentless, uninvited motion has irrevocably redefined what it means for science to know. When the passage finally ends, and 3I Atlas drifts silently back into the dark and the silence of interstellar space, it will leave behind much more than just calibrated data. It will leave a community of humbled experts and an audience reminded that control over information is, and always has been, a temporary illusion. The object will continue outward, older than all human doubts and systems, carrying the quiet, undeniable proof that truth always endures exposure, and that the final mystery remains unclosed and justly unresolved. The enduring questions that began as alarm have settled into a deep, measured comprehension, and the object's journey reflects humanity's own, a quiet, sustained movement from intellectual dependence toward hard-won discernment, proving that the universe rewards observation, not simple belief, and reveals itself only to those willing to admit how little they actually know. Its path, its strange chemistry, and its unpredictable motion form a triad of open questions that remain alive long after it fades from sight. An enduring symbol of renewed attention where the tension between known and unknown dissolves into a tranquil acceptance that both belong to the same cosmic fabric. The careful observers, grounded by verifiable evidence, discover in its motion a quiet, lasting reassurance. Reality, when witnessed honestly and without institutional filter, always leaves a measurable, unforgettable trace.